The question says a ray of light is incident on the surface of a block of clear ice at an angle of 48 degrees with the normal. Part of the light is reflected and part is refracted. Find the angle between the reflected and refracted light. So here's what's going on. We have a block of ice, and we have, let's say that this is the normal to the block of ice. We have a ray of light hitting this ice at an angle of 48 degrees, and then part of it is reflected at the same angle, and part of it, and I want to change the color here, part of it is refracted, and this angle is going to be a little bit different. So let's define these angles. So this is theta 1, theta 2, theta 3, and the angle between here and here we'll call theta 4. And the problem is asking us to find theta 4. So without knowing anything about these angles, I know that the angle between here and here is 90 degrees. So if I wanted to find the angle between here and here, I could say that the angle between here and here is equal to 90 minus theta 3. So 90 minus theta 3 gives me part of theta 4. And then I also know that the angle between here and here is 90 degrees. And so if I want to find the angle between here and here, I can say that this is equal to 90 minus theta 2. So is equal to 90 minus theta 2. This will give me theta 4. So when I add these together, it will give me the angle between here and here plus the angle between here and here. So that is theta 4. Now real quick, we know because the law of reflection that the angle theta 1 is going to equal angle theta 2. And so we can go ahead and replace and substitute theta 2. And so what that's going to equal is we'll have 90 minus theta 3 plus 90 minus theta 1. And we don't have to put any number on theta 2. And that's going to equal all theta 4. Now the only unknown, so we have theta 4 as an unknown, but the only other unknown we have is theta 3. We can find that using Snell's law. So the sine of theta 1, so n times the sine of theta 1 is equal to n2 times the sine of, we'll call it theta 3. And so N2 is the index of refraction for my ice block. And so I want to solve for theta 3. And the way you'll do that is divide by N2. So N1 over N2 times the sine of theta 1. And I take the so that's going to equal the sine of theta 3. And I just take the inverse sine of both sides. And what I get is that the inverse sine to the negative 1 of N1 over N2 times the sine of theta 1 is equal to theta 3. And now that I've solved for theta 3, I can take this equation and I can plug it in right here in theta 3. So I'm going to go ahead and do that. So 90 minus theta 3, so the inverse sine of n1 over n2 sine of theta 1 plus 90 minus theta 1 is equal to theta 4. Now if we assume that whenever that light is in our block of ice out here, it hits, part of it's refracted, part of it's reflected. If we assume that this is air and that this is ice, the index of refraction for air, N1, so N1 is equal to 1.000293, and N2, ice, is 1.309. And so where am I getting these index of refractions? You just have to look them up in a chart. They're experimentally determined. But once you know them, you just plug them into your equation. And so what I got for my angle, for the angle between the index of refraction and the reflected beam, the angle between the refraction and reflected beam was 97.39707 degrees. Hey, thanks for watching. Make sure you check out my blog. The link is down in the About section of this video. And on the blog, you'll find cool stuff like other videos for the same chapter. And you'll also find little download links where you can download calculators to basically just punch in your numbers and solve these exact problems. So you won't even have to watch the video if you don't want to. The last thing I want to say is if you leave comments on YouTube, of course I will get around to responding, but I'm much faster if you leave them at the bottom of my blog, right down there. Enjoy your day.